welcome algebra class. This is our rerun of a lesson on weighted averages. Basically, this class, go ahead and show them. They loved this lesson so much when we did it the first time that we're going to do it again. Because this book, I feel like it didn't do a real good job of teaching it, and I did a poor job of teaching it the first time. So this is weighted averages take 2. Yesterday, I was a little frustrated with this unit. I read it in the book, and I feel like they didn't explain it very well, so I went on a run, and it took me 7 miles to figure out how to teach it. So I'm going to try it right now. Here we go. You guys, the audience, live audience,
Yeah.
I've given you 10 numbers here. Give me the average, the mean of those numbers.
6.8.
The mean of all 10 is 6.8. Okay, do you agree?
Yes.
Let me tell you a statement and see if this makes sense to you. The average of 2 averages is rarely the average. Does that make sense?
No.
Well, let's prove it right now. If we group, let's say, these 2 numbers together, and we group these 8 numbers together. Let's figure out the average of these 2 numbers. 9 and 11 adds up to 20, divided by 2. The mean of that would be 10. Do you agree?
Yes.
These numbers add up to, I can't remember, I had it, somebody do it quick. 11, 16, 21, 30, 36, 43, 48. And we divide it by 8, and so the average of those is 6. Do you agree?
Yes.
Let's take, so this is the average of the first 2. This is the average of the last 8. Let's do the average of these 2. 10 plus 6 is 16, divided by 2 gives you an average of 8, right?
Yes.
Do you see that 8 is not really the real average? So I can say my statement again. The average of 2 averages is rarely the average. Okay? It really does hardly ever work that way. Now, here's the real question. Can you look at this and tell me why does the average of this, when I took the average of that, and I took the average of this, and then I take the average of those 2, why does it not turn out to be the average? What's going on? So talk amongst yourselves for a second. Okay. We're going to get an answer from some of the more brilliant people in the crowd. Jackson, you can show this gentleman. Why, Ben?
I think it's because some of the numbers are weighted differently.
What do you mean weighted?
More of one set of numbers than the other.
Correct. Okay. Look, out of these 2 groupings, there's only 2 numbers that make up that mean, but there are 8 numbers that make up that mean. Does that make sense?
Yeah.
So it's like these 2 people are getting an artificial, and then if we do, there are 2 numbers that make up that, there's 8 numbers that make up that, and then we're counting them like they're almost exactly the same, because we're taking the mean of those 2 items, as if that represents just as many people as that did, but it doesn't. This is an unfair distribution. When I take the mean of those 2 numbers, they're giving a lot of input into that, and then these 8 are all cramming into that, and then when I divide them by 2, these 2 numbers get an artificial amount of influence on the actual end product. Does that make sense?
Yeah.
So do you see that when I do this, the end product ends up being higher than what the real mean is? Because those 2 numbers happen to be kind of high, and they're giving a lot of influence in the final decision when they shouldn't. It's a little bit like this. Let me give you a real example. Let's say that we had an election here at school for homework policy or something like that. All of us, the teachers and the students, got to have input on the new homework policy. And after we made these presentations, we all voted, teachers and students. And then what we did was we took I don't know how many teachers there are. Let's say there's 30 teachers. We took the 30 teachers and we took the average of our votes. And then we took all the rest of the students, 400 and whatever there are of you guys, and we took the average of your votes, and then we averaged the 2 votes together and got the final product. Would that be fair?
No.
Why?
Because there's less teachers.
Exactly. that's giving us too much influence in the final say. Does that make sense?
Yeah.
Just like when I do the average of these averages, it's giving these two people too much influence in the final say. So weighted averages is really just a way to try to get like a fairness or a way to find out the final average but have it be more fair. Does that make sense? Yeah. All right, this is what I'm trying to get across. Let's do an example. Let's say that you were taking a test for math class. Okay, you took 3 tests during the regular trimester, and then at the end of the trimester you took a final. Your 3 tests, I tried to get some numbers that just kind of worked here, so let me just write down what I got. Your 3 tests that you took, you got a 72 on one of them. Didn't do so well. I know. You got an 86 on the next one.
Better.
And then it was right before Christmas and you got 62. Okay? Bad. Then we come along to the final though. And the final is weighted times 2. It's 2 times what you actually get on it. They want it to be, the teacher wants it to be twice as important as a regular test. And you, by a miracle, get 100 on your final. So how am I going to figure out your average for the trimester? I could add these up. These add up to be 220 plus that 100, and I can get 320. And I divide it by 1, 2, 3, 4, and that means you got an 80. Is that fair?
No.
What's wrong with it, Matthew?
The 100 doesn't get more.
I didn't give it that extra weight, so it didn't turn out to be fair. So if I double this and actually like count it twice, now it's going to kind of add that extra weight to it. Does that make sense? So now what I'm going to have to change is instead of it turning out to be an 80, it's going to be 420. And what am I going to have to divide by this time?
5.
By 5 scores. Another way I could have written this, let me just do it a little more plain. I could have written 72 plus 86 plus 62 plus 100. And then instead of writing 100 plus 100, I could write 100 times 2. Does that make sense to everybody?
Yeah.
And now when I divide it, it's by 1, 2, 3, and it's actually 5 scores. So I divide it by 5, and then when I do it, what's 420 divided by 5?
84.
Is what?
84.
You get an 84 now instead of an 80. So basically by properly weighting this, you got an extra 4 points on your grade. Does that make sense? Okay. So are you starting to kind of get weighted averages now? It's a way of kind of like counting things that are more fair. The problem with the book then is, I think this all makes sense, is then they jump into these really confusing examples, and also I feel like some of the examples they're using is not even weighted averages. So let's do one of them, and I think I can explain the one in the book, and then we'll talk a little bit more. Okay? So look at, is it the example 1? Look on page 132. And it's real world example 1. The dreaded mixture problems. Do you remember those? Okay. But I'm going to try to explain the mixture problems not the way that the book does, because I don't think they give any rationale and I think it gets you really confused. Let's do it my way. So the first mixture problem. It says a tea company sells blended tea for $25 per pound. To make blackberry tea, dried blackberries that cost $10.50 per pound are blended with black tea that costs $35 per pound. How many pounds of black tea should be added to 5 pounds of dried blackberries to make blackberry tea? So, we're going to have a couple things mixed together, and we want the total end product to be how many dollars per pound? $25, right? We want it to be 25 bucks per pound. There's going to be something here that's a little cheaper. There's going to be something here that's a little more expensive. But when we add them together, and what are we going to have to divide by? Basically the amount, right? the amount of times like that's the weighting system, you're going to want it to turn out to be 25 bucks. The blackberry tea, okay, it says they're going to give you 5 pounds of dried blackberries, and the blackberries cost $10.50 per pound, right? So those are $10.50 per pound. And remember, we have to do that, the number of times that they give it to you. They're giving it to you 5 pounds worth. So it's like 5 times $10.50. Does that make sense? Yeah. $10.50 plus $10.50. They're just writing it like that. And then they're saying we're using the black tea, which I forgot how much it costs.
$35.
This is more expensive. But we don't know how much to mix it with. So what do you think you're going to use here? Just use any old variable. So now stop for a second and think. This is the number of pounds, and it's that much per pound. This is the number of pounds, and it's that much per pound. So what are we going to divide by down here to figure out how much we want this to be $25 per 1 pound. So what are we going to divide by, Mike?
5 plus X.
We're going to divide by the number of pounds, right? That's right. And the number of pounds is 5 plus this unknown that we don't know. So we're going to divide it by 5 plus X. Okay? The problem with your book is they always show this crazy table, and then they have this being multiplied by that, which you understand algebraically is fine, right? You can divide by something and then move it to the other side of the equation and multiply it by it. But they never tell you why they do that. So it's the number of pounds at this price, the number of pounds at this price, divided by the total number of pounds. And that's we want that to be $25 per pound. And so when you do it, you're going to just move this over and multiply it, 5 plus X, right? And so this will be, what's 5 times 1050? Somebody? $52.50. And then this is going to be 35x. And we moved this over to this side. And it's going to be $25 times 5, which is going to be $125. And $25 times x, which is 25x. Can you see that, Jackson, on the thing? All right. So now we're just going to solve. Let's get the x's on one side and the numbers on the other. I'm going to move these x's over here and subtract them. That leaves me 10x over here. I'm going to take that money and move it over here and subtract it. Somebody do 125 minus 5250 for me. It's what? 7250. And then we're going to divide by 10, which just moves the decimal place over once, right? So x is 7.25, what unit?
Pounds.
Pounds. And that's the pounds for the black tea, I forgot. Okay, does that make sense to everybody?
Yep. Yeah.
All right. So that's the simple formula. Don't look at their chart. I think it's going to mess you up. They always move this over there and they multiply it, but they don't tell you why, and you never know what's going on. Okay, I think that's probably going to be the end. I don't know if that's 15 minutes, so we're going to call that quits, and I'll see you tomorrow, Algebra.